Okay, so here I'm going to walk you through how I'd fill out the lab report given the numbers I used in the previous video overview of the lab. We'll often start out our labs with a question asking you to come up with an estimate or guess of one or more of the numbers in the lab. That can be challenging because before you've done the lab, you may not be familiar with what kind of numbers you'll get. It's okay if at the end of the lab your prediction is not correct. That's fine. You'll just mention it. Something like this, I don't have a great sense of how much energy I use going up the stairs. I'm going to guess it's about 1 food calorie. It's just a total ballpark guess, which is about, what did it say, 4,800 joules, and that's closest to 1,000 joules, which is 10 to the third power. Except I don't remember how to do the superscripts as I'm typing. Oh wait, I just saw it. Let me get the joules in there. And that didn't work. Okay, 10 to the third joule. So now it's asking about the power. So a watt is a joule per second. I'm going to ballpark guess, I'll just use the same number I used in the lab, that it takes me 180 seconds to go up the stairs. And if that's the case, then the power would be, what did I get for the energy? I got that rounded value of 1,000 joules. Divide that by 180 seconds, and I get 2.6 joules per second, which is 2.6 watts. Oh, I should probably put words in there. And so we're asked what the closest power of 10 is. Closest power of 10 is 1. So we'll round that down to 1 for the purposes of this question. There'll be several times in this course where we decide to round things or go with the nearest power of 10 because it'll give us the right ballpark of what's going on. And we really want to try to keep the focus on the big picture, not get caught up in calculating everything out to the last decimal point. So you'll need to look at the previous video to see where I'm coming up with the numbers here, but my backpack was about 10 pounds, and that turned into 40 newtons, and it was 7.1 meters up the stairs, and it took me 180 seconds. And I guess I should mention here that, whoops, that's not what I wanted. I converted the weight in pounds to the weight in newtons by multiplying by 4. So the first, in this next one, the first thing I'm doing is writing down the work I got in Newton meters or joules. So that's the weight of the backpack in newtons times the height, 7.1 meters, and that worked out to 280 joules roughly. As discussed in the previous video, you need 4 times that in terms of food input, because only 25% of what you eat turns into useful work. The rest of it goes into keeping you warm, keeps up your body temperature. And that energy in kilowatt hours, I believe, was 0.003 3 kilowatt hours. And, to do this conversion, let's say I multiplied by 4 to get the chemical energy. And I used Google to convert from joules to kilowatt hours. Okay, then last thing we calculated was the power, and if I'm remembering correctly, that power was 6.2 watts, which turned out to be 0.15 kilowatt hours per day. And again, add a short explanation of what you did. So to get power in watts, I divided the chemical energy by the time it took me to go up the stairs, and I used that magical conversion factor divided by 41 to get the power in kilowatt hours per day. Okay, so let's see. The last question is asking, so first to compare with the predictions. So let me look back up at my predictions. I said that I was going to use a food calorie that was about 4,800 joules, and it would actually turned out to be 280. So my estimate of the energy required was off by roughly a factor of 5. And let's see, so we'll also say something about whether the joule or kilowatt hour is the more convenient unit here. In this, there's not a right answer or a wrong answer here. I kind of prefer using joules here because it's easier for me to read a number like 1120 and know what it is rather than having to think what 0.0003 is. So I'd say that a joule is the better unit for this energy. For the power, I think you can make an argument either way. 6.2 isn't that hard for me to understand. 0.15 isn't that hard for me to understand. I don't think that for the power that it matters too much. So you'll put in whatever you decide in your lab, but I wanted to give you an overview of what a completed lab report would look like given the calculations that we did earlier.